Trigonometry, Chapter 2, Acute Angles and Right Triangles, Section 2, Trigonometric Functions of Non-Acute Angles, Video 3, Expressions Involving Special Angles. This series is based on content from Pearson's Trigonometry, 12th edition by Lyle, Hornsby, Schneider, and Daniels. In the last video, we learned how to use reference angles to calculate trig values for other angles. In this video, we will simplify expressions involving special angles. For example, let's simplify sine of 45 degrees times cosine of 30 degrees plus sine of 30 degrees times cosine of 45 degrees. Full disclosure, there's nothing new or no trickery to this problem. This is simply finding the values, substituting them, and then evaluating them. So if you want to pause the video and try to do it before I explain, by all means, go ahead. There will be some problems at the end of practice as well. But I digress. All of these trig function values can be found directly from the 45-45-90 and 30-60-90 triangles. These two triangles, which you need to have memorized. From that, we can deduce that sine of 45 degrees and cosine of 45 degrees are both square root of 2 over 2. Initially 1 over the square root of 2, but the denominator gets rationalized. Cosine of 30 degrees is square root of 3 over 2, and sine of 30 degrees is 1/2. So all we have to do is literally substitute these into the expression and clean it up. So let's do that. Here's the expression before substituting the values. Both 45-degree functions will become square root of 2 over 2. Cosine of 30 degrees will become square root of 3 over 2. Sine of 30 degrees will become 1/2, like that. Then we just clean it up. We can multiply each pair of fractions, which will give a denominator of 4. In the first two fractions, the square root of 2 times the square root of 3 will give the square root of 6, but 1 times the square root of 2 will just give square root of 2 on the second product, and have something like that. At this point, it's pretty much simplified, but because we are adding two fractions and they already have a common denominator, we might as well merge them into a single fraction and say that our final result is the square root of 6 plus the square root of 2 all over 4. Now, later you'll see that this is exactly the value of sine of 75 degrees, and I'm sure if you look back up here at the original expression, you'll see where the 75 came from, but that's later. How about this one? Simplify cotangent squared of 90 degrees minus secant squared of 180 degrees plus cosecant squared of 135 degrees. Now, if you're thinking same song and dance, the 90 degree and the 180 degree, those are a little bit different because those two are quadrantal angles. We don't use reference angles on those. We use pictures and definitions. For cotangent of 90 degrees, its terminal side is on the positive x-axis, so we can use any point on the positive x-axis to calculate its value. We'll use the point 0, 1 and calculate that cotangent of 90 degrees, which is x over y, would be 0. And similarly, for secant of 180 degrees, we can use any point on the negative x-axis because that's where its terminal side lands. We'll use the point -1, 0 to calculate that secant of 180 degrees, which is r over x, is equal to -1, since r is 1 and x is -1, pardon me. Now for cosecant of 135 degrees, observe that 135 degrees is in quadrant 2, and therefore has a reference angle of 180 degrees minus 135 degrees equals 45 degrees. And in quadrant 2, sine and cosecant are both positive, in particular cosecant. So cosecant of 135 degrees is equal to positive cosecant 45 degrees, which is the square root of 2. And now we substitute all the values into the expression. And the expression collapses down to 0 squared minus -1 squared plus the square root of 2 squared. Well, square all three numbers, keep the minus and plus, gluing them together to get 0 minus 1 plus 2, and that's just 1. So that big scary trig expression was just equal to 1. All right. Now you try. Pause the video and try the following. Simplify the following expressions. Spoiler alert, I planted a couple of tricks in both of these, but you can work them straightforward. All right, if you haven't paused the video, here's your fair warning. Solutions in 3, 2, 1. Oh, and the things that I planted, it says in the answers. You could have used identities to simplify both of these without actually knowing any of the values of the individual trig functions.